Asteroids are primordial remnants left over from the formation of the solar system billions of years ago. When the giant Jupiter began to form, its powerful gravity disrupted the accumulation of material in the region between Mars and Jupiter. Instead of coalescing to form a new planet, countless small objects collided, broke apart, and collided again, creating the asteroid population we observe today. Over time, rotation, thermal forces, and gravitational interactions with larger bodies have caused some asteroids to stray from their original orbits and travel deeper into the solar system, some of which have become potential threats to Earth. Among them, the most prominent is Apophis, an asteroid that caused a stir when it was discovered in 2004. On April 13, 2029, Apophis will pass by Earth at a distance of only about 31,600 to 32,000 kilometers, lower than the position of geostationary satellites operating in orbits of 35,000 to 36,000 kilometers. This means it will pass right through humanity's important satellite corridor, where communication systems, weather warnings, and global positioning systems are concentrated. Although the probability of a satellite collision is very low, the closeness of the event still causes international space agencies to continuously assess the risks and closely monitor each parameter. According to updated orbital simulations, Apophis will be bright enough to be visible to many in the Eastern Hemisphere, with the naked eye moving slowly but distinctly like a stray star sliding across the night sky. For the general public, it will be a rare astronomical spectacle. But from a scientific perspective, it will be a unique natural experiment, a chance to directly observe how Earth's gravity acts on a large object put into extreme stress. Recent models suggest that this tidal force could alter the rotation rate, even slightly deform the internal structure or cause rock slides and shaking of Apophis's surface during its flyby. Global scientific interest has surged as agencies like NASA and ESA have announced plans to monitor Apophis on an unprecedented scale. Powerful radars at multiple observatories will be used for months to precisely measure its three-dimensional shape, density, mineral composition, rotation rate, and any structural changes before and after the approach. In particular, Europe is proposing a RAMSES mission, scheduled to launch in 2028, to reach Apophis just as it approaches Earth. If deployed, RAMSES would become the first probe in history to directly observe an asteroid while it is under the strong influence of Earth's gravitational field, providing unprecedented data on its material cohesion, internal structure, and physical behavior in real time. Radar data collected in 2021 has helped researchers determine Apophis's orbit with great precision, thereby completely eliminating the risk of collision with Earth for at least the next 100 years. However, scientists still maintain vigilance because the asteroid's orbit can change if it collides with another small object in space, although the probability of this is extremely low. It is this ability to change subtly that makes Apophis continue to be the subject of long-term monitoring, not because of old fears, but because of the great scientific value it brings. While researchers focus on the science, social media conspiracy theories continue to captivate the public. Some suggest that Apophis's orbit is changing as if influenced by an unknown gravitational force. Others imagine it could be an ancient piece of man-made debris or a surveillance device from an extraterrestrial civilization. While there is no evidence to support these theories, the allure of the mystery has helped keep the 2029 event a center of fascination for both scientists and the public. Despite much speculation, what is clear is that the Apophis 2029 event is both one of the most spectacular astronomical moments of the century and a reminder that Earth is not alone in space, but faces a multitude of cosmic objects that are completely unpredictable. It is also a testament to the need for planetary defense programs in the future. If just one object is not detected in time, or its orbit is misjudged, humanity could face an event that could reshape the climate and life on Earth, similar to impacts that have occurred in the planet's ancient history. Asteroid 99,942 Apophis, a name that shocked the scientific community when it was first discovered, because the possibility of a collision with Earth could not be ruled out at that time. Apophis is in the category of near-Earth objects, which includes asteroids and comets that have orbits that come dangerously close to our planet. It orbits the Sun in less than a year, and its orbit intersects directly with the Earth's orbit, forcing any calculations related to it to be done with higher precision than usual. Apophis' membership in the S-type asteroid family makes it a particularly interesting target for observation. This group includes asteroids with orbits smaller than Earth's, but which intersect our planet's path. The structure of Apophis' rocky crust and unstable rotation have also led many scientists to wonder whether its interior contains porous spaces or even natural structural cavities that could be disrupted by the force of Earth's gravity. Some theorize that the asteroid's rotational fluctuations could be caused by ancient impacts or by the Yarkovsky effect, a phenomenon in which thermal radiation causes small objects' orbits to change over time. During its 2029 approach, Earth's gravity will act as a cosmic lever that will significantly shift Apophis' orbit. After this powerful gravitational tug, it will leave the A10s group and move into the Apollo group, a group of asteroids with larger orbits that still cross Earth's path around the Sun. That means Apophis will continue to be an object to watch closely for decades to come after 2029. It's rare for an asteroid to change classification after passing close to Earth, making researchers all the more eager to track it. Some experts believe the sudden orbital change could reveal unusual physical features of Apophis, such as uneven density or the possibility of fragmented clumps of material inside. Conspiracy theorists, on the other hand, question why Apophis' orbit is so sensitive that even a passing pass could change its classification. Does it contain previously unknown ultralight matter? Is its orbit being influenced by some other unseen force? While there's no hard evidence, the suspicions have only added to the global spotlight on Apophis' journey. What is certain, though, is that the 2029 approach will be a golden opportunity for scientists to directly observe how Earth's gravity interferes with the orbit of a large object. And as Apophis continues to travel through space on its new orbit, Earth must keep a watchful eye, because even if it changes course, it will still be a visitor with the potential to return in the future. Since its discovery in 2004, Apophis has quickly become the focus of global concern, not only because of its size, but also because early calculations suggested a real chance of impact with Earth. According to early models, the chance of impact is small but not negligible, and in the worst-case scenario, Apophis could release the equivalent of about 880 megatons of TNT. This far exceeds any man-made explosion ever recorded in human history and creates enough energy to shake the entire planet. To put that in perspective, Arizona's Barringer Impact Crater, one of the most prominent in the United States, was created by an explosion estimated to be between 3 and 10 megatons. Yet today, Barringer has left a crater more than a kilometer wide and nearly 200 meters deep. Put those two numbers side by side and you can see the huge difference. Apophis would have hit with tens to hundreds of times more force. An impact of that size could flatten an area of thousands of square kilometers, destroy everything within a radius of hundreds of kilometers, and create a huge dust cloud capable of affecting the global climate. In simulations, if Apophis had hit the ocean instead of land, the consequences would have been no less dire. The 880 megatons of energy would have created a giant water column, followed by tsunamis far beyond any recorded disaster, reaching hundreds of meters near the impact center and spreading thousands of kilometers out to sea. These scenarios, though only on paper, were enough to keep space agencies on their watch lists for years. Even early on, there were concerns that Apophis might enter a gravitational keyhole in 2029, a small region of space through which, if it passed, its orbit would be warped enough to collide with Earth on its return in 2036. Although more precise observations have since ruled out that possibility, the specter of a collision scenario has made Apophis a symbol of potential cosmic hazards. And while the probability of an impact has now been reduced to almost zero, simulations of the enormous energy it could release are a reminder that objects like Apophis are not science fiction, but a very real threat that Earth needs to prepare for. Apophis comes from what is known as the main asteroid belt, a vast region between the orbits of Mars and Jupiter that marks the natural boundary between the inner rocky planets and the outer gas giants. It is home to millions of ancient rock fragments, remnants from the formation of the solar system more than 4.5 billion years ago. They are considered primordial samples, preserving the original chemical composition of the universe, representing material that never coalesced into fully formed planets. For billions of years, the powerful influence of Jupiter's gravitational field has been exerting a constant influence on the small objects in this belt. The uneven stretching of the giant's gravity has caused many asteroids to become unstable, deviated from their original orbits, and pushed onto new paths. Apophis is one of those ancient fragments which was hit by Jupiter as a strong push and launched into the inner solar system. Since then, it has become a wandering object with an orbit that periodically crosses the path of the Earth, attracting special attention and close monitoring from scientists. Compositionally, Apophis is a Type S asteroid, or silicate asteroid, one of the most common groups in the asteroid belt. The main components of this group include rocky silicate minerals combined with metals such as iron and nickel. Spectroscopic observations indicate that the surface of Apophis is quite reflective, consistent with the bright characteristics of rocky metallic asteroids. This makes it much easier to observe than the darker S-type asteroids. Radar analysis suggests that Apophis is not a single, cohesive mass of rock, but rather a type of cemented rubble, a collection of many pieces of rock held together by weak gravity. This explains its unusually distorted shape and suggests that it suffered one or more violent impacts in the distant past. These impacts may have broken apart a larger body before the fragments coalesced into the structure that Apophis is today. Its irregular shape and unique way of reflecting light has led many scientists to question its internal structure. Some models speculate that Apophis may contain layers of material or even large cracks hidden deep within, remnants of ancient impacts. This raises concerns that during its close approach to Earth in 2029, gravitational tides could cause small fluctuations in its already unstable structure, altering its rotation rate or even causing its surface to peel or slide. Despite its many unanswered questions, Apophis is considered a living relic of the early solar system. Each of its orbits around the Sun carries valuable clues about the history of celestial formation, and its accidental crossing of Earth's orbit has made its journey the subject of a worldwide watchful eye. During its close approach in 2029, Apophis will not only skim dangerously close to Earth, but will also be hit hard by our planet's gravity. Simulations suggest that this could alter its already unstable rotation, leading to internal oscillations known as asteroid seismicity. These oscillations could shift loose rock on the surface or trigger earthquakes, which could slightly alter its shape or even its trajectory as it returns to the inner solar system. While these changes may be small, they could be enough to alter the long-term behavior of an object hundreds of meters in size like Apophis. For years, Apophis has been at the top of the list of most worrisome near-Earth objects. Global risk assessments have placed it in the highest probability category, forcing scientists to constantly update and recalculate its trajectory. Each new measurement, each new observation brings with it the hope of more precise information, but also adds to the suspense, as even a slight deviation in the data could alter predictions of its future. As of March 2021, there was still a small but worrying possibility that Apophis could collide with Earth in 2068. Although that probability was very low, the fact that it could not be completely ruled out made Apophis the focus of many intensive observation programs. However, the turning point came in 2021, when a large-scale observation campaign using the powerful radar systems of observatories such as Goldstone and Arecibo, before they were shut down, recorded Apophis's orbit with unprecedented precision. This sharp radar data shows that Apophis's orbit is not as affected as previously predicted by the Yarkovsky effect, a phenomenon that causes deflections in the orbit caused by thermal radiation from the asteroid's surface. As a result, all near-term impact scenarios have been ruled out. Thanks to the new quantitative data, researchers have declared that Apophis will not pose a threat to Earth for at least the next 100 years, removing it from the high-risk watch list and bringing temporary peace of mind to humanity. But safety doesn't mean Apophis is no longer a topic of interest. The 2029 approach is still considered a unique opportunity to directly observe how Earth's gravity affects such a large object. And while the risk of a collision has been ruled out, small changes in its rotation or internal structure could raise new questions. How will Apophis's orbit change over the next 100 years? Could it return to a more dangerous orbit? These questions keep Apophis's journey under constant scrutiny, both with scientific curiosity and with unwavering vigilance. Today, Apophis is no longer seen as an imminent threat, but as a unique natural laboratory hurtling toward Earth. The 2029 approach is considered the most scientifically significant astronomical event in decades, with researchers around the world expected to mobilize telescopes, radar systems, and probes to monitor the asteroid's smallest changes. They hope to observe its surface structure, mineral composition, three-dimensional shape, rotation, and how the loose materials on its surface respond to Earth's strong gravitational pull. The significance of the event is further enhanced by the fact that Apophis is a rare specimen that helps humanity better understand how the forces of the solar system shape the orbits and evolution of small objects. What was once a source of concern has become a window into complex mechanisms such as how gravitational tides can tear an asteroid apart, or how its rotation speed can increase or decrease just by passing close to Earth. At the same time, detailed observations of Apophis could help strengthen future planetary defense strategies, including the ability to detect, track, and even deflect objects with dangerous orbits. Several space agencies are even considering deploying probes to Apophis during its flyby, making it an unprecedented